Welcome to day 29 of our 101 Days of Data Science journey. Today, we'll dive into the fascinating world of multivariate analysis. Multivariate analysis examines how multiple variables interact with each other. This type of analysis helps us uncover relationships and patterns that single or bivariate analyses might miss, providing deeper insights into our data. Let's start with principal component analysis, or PCA. This technique reduces the dimensionality of data while preserving its essential features. It's particularly useful when we have many variables and want to simplify our analysis without losing important information. In this code, I first created a small dataset with two features. Then, I used standard scalar to standardize the data, which is an important step before applying PCA. Next, I applied PCA using PCA from the Sklearn library, specifying that I want two principal components. Finally, I printed the transform data, which shows how the original features are represented in a reduced dimensional space. The output shows the values of the first two principal components for our dataset. Each principal component is a linear combination of the original features that captures the most variance in the data. Principal component 1 captures the most significant variance, with values ranging from approximately 1.8 to about 2.1. The negative values indicate that the observations are located more towards the lower end of this component, while the positive value, 2.1, indicates an observation that is further away in this direction. Principal component 2, on the other hand, captures less variance, with values close to 0. This suggests that while there are some variations along this axis, they are less significant compared to principal component 1. Now let's move on to heat maps. These visualizations allow us to see correlations between multiple variables at a glance. Heat maps make it easier to identify patterns in complex datasets, providing a clear visual representation of data relationships. In this snippet, I first calculated the correlation matrix of our dataset using the core method. Then, I used Seaborn's heat map function to create a heat map where the colors represent the strength of the correlations. The anode true parameter adds the correlation values to the heat map, making it easy to interpret. This heat map shows that feature 1 and feature 2 have a perfect correlation 1, meaning they move together in the same direction. Since they provide identical information, one could be dropped to reduce redundancy. Multivariate analysis, with techniques like PCA and heat maps, helps us uncover complex relationships between multiple variables. These methods enrich our understanding of the data, allowing for more informed decision-making and analysis. In our next lesson, we'll tackle the important concepts of correlation and causation and clarify the difference between these fundamental ideas.